This is Environmental Science 2, Chapter 6, Part 1 on air pollution. In this portion of the video lecture, we will be discussing the causes of air pollution. Basically, what air pollution is when harmful substances end up in the air. Human activities, of course, can provide quite a bit of these pollutants. Pollutants in air can be in the form of solids, liquids, or gases. Generally, industry puts a lot of those harmful substances up in the air. Natural resources also can actually cause air pollution. So the earth itself can actually cause some gases and things. For example, volcanoes can spew clouds of particles and sulfur dioxide that can suffocate animals. So it's not just human activities that cause air pollution. The earth itself can also get harmful substances to end up in the air. When we take a look at pollutants, we can separate them into two different categories. Primary pollutants are those that are directly put in the air by human activities. For example, a primary pollutant would be soot from smoke from a factory. Secondary pollutants are formed when other primary pollutants come into contact with each other. So example, a secondary pollutant would be when we have soot from smoke reacting with a natural substance like water vapor that's in the air, and we can get that chemical reaction that take place to cause smog. So primary and secondary pollutants are at varying levels in the atmosphere. Most primary pollutants are things like transportation. So our vehicles, either individual vehicles or city transportation vehicles like buses or cabs, or transportation and shipping vehicles like semi-trucks or even barges and cargo ships that have to travel on the ocean. Put those primary pollutants into the air, and they can start mixing together with a whole lot of other things in the atmosphere to cause secondary pollution. Mainly what we've got going on today with car exhaust being the majority of the primary pollutants that are put into the air by human activities. About 1/3 of the air pollution is from car exhaust. In the 1970s, there was the Clean Air Act that was passed. What it does is it gives the Environmental Protection Agency, or the EPA, some authority to control car exhaust emissions. So the EPA will have authority to control car emissions, and they also required the elimination of lead in gas. Catalytic converters in cars will take a lot of those primary pollutants out of the combustion process, or at least kind of reduce them so they're not at as harmful levels previous to 1970. The Clean Air Act was revised a bit in 1990 to kind of continue those efforts to reduce those different types of primary pollutants from car exhaust. Nowadays, we also have the alternative fuels, things like biodiesel, or in some cases, hybrid or electric cars can also reduce those types of emissions as well. Industrial pollution is another main violator of our skies. Burning fossil fuels releases a whole category of pollutants that we call oxides, because they have oxygen attached to them in some way, shape, or form. We can have carbon monoxide. Nitrogen oxides are very polluting. They come from burning fuels in vehicles, power plants, industrial boilers. Sulfur dioxide can come from petroleum refineries, places like paper mills, or chemical plants, and of course coal burning power plants, which is how we get the majority of our electricity. We call these oxides VOCs. They're very volatile organic compounds, and they come from toxic fumes, mostly from manufacturing processes in industry. The Clean Air Act helps control those levels of VOCs, or volatile organic compounds. Industries need to use and are required to use pollution controlling devices to minimize their emissions. One of the ways that industry can do this is putting in place what's called an air scrubber into the manufacturing process. Air scrubbers remove some of the more noxious substances that would otherwise get into the air. So what happens is gases kind of move through a spray of water, and that dissolves a lot of the pollutants, and that can kind of eliminate some of those lighter types of gases that would normally get up and out. That way they can be trapped into water and be taken care of from there. Electrostatic precipitators are used a lot of times, for example, in cement factories and coal burning power plants to remove particulates from smokestacks. Particulates would be a solid type of air pollution. So through static electricity, we can get some of those heavier types of pollutants out of the air. Thermal inversions are a natural way that the Earth helps keep the amount of VOCs at a low. So the air circulation itself can help kind of disperse those different pollutants in the air so they don't get concentrated in one particular place. What can happen in some places, especially if you're in a valley or a low-lying area, is what's called a thermal inversion. Thermal inversion traps pollutants near the surface, and warm air, which will normally rise, gets stuck at a lower level because cool air will kind of be above and below the warm air, and so everything will get trapped towards the surface. So during the day, the sun heats the surface of the earth and the air near it. The warm air then will rise through the cooler air above, carrying pollutants away in normal situations. In the bottom of the diagrams here, what ends up happening is the air in a thermal inversion, the air above is warmer than the air below. So things get trapped near the surface. So the warmer air above keeps the cooler air at the surface from moving upward. So everything gets trapped. Again, if you're in a lower area, a valley, there are frequent thermal inversions in those types of areas. Smog is air pollution that will hang in human air. It is one of those secondary types of pollutants because smog needs to have a chemical reaction. So we're going to be making kind of a new product. We'll need sunlight, lots of those oxides, different types of oxide chemicals, and hydrocarbons from fossil fuels. Cities that suffer most from fog have a lot of traffic. They're usually located in very dry and sunny areas. In the U.S., for example, places like LA and Denver are kind of known for their smog and their emission controls that they have to have on their vehicles because of the level of smog in the air. Mexico City is another city that's known for its thermal inversions and for its high levels of smog in the area. This has been Environmental Science 2, Chapter 6, Part 1 on air pollution.